Okay, so we got this expression for case 1, that is, yeah, we substituted the value of 1 by ue, this one, in this equation, and we got this value. And you can see that if this d and this d will get cancelled, there will be only 1, so 1 plus d by f. This is the expression for magnification when the object is at when the image is at least distance of distinct vision, or in other word we can say this is the maximum magnification. Okay, case 2. Case 2 means normal adjustment. Normal adjustment means relaxed eye. That means in the previous case, means in this case, the image was formed at least distance of distinct vision. So if you see that the image is at least distance of distinct vision, means only 25 centimeter away from our eyes, and in that case still our eyes, it needs some, or it gets some strain to focus the object, so to focus the image, because it is too far, too near to our eyes, only 25 centimeter, right? But if the object is far, in that case we can observe, or we can look at the object in a relaxed way. So this is relaxed eye, or this adjustment is called normal adjustment when the image is at far distance or far away. Where is the image? The image is at infinity. Okay, so when the image is at infinity, what will be the changes? The changes will be v, this time will be infinity. In the previous case v was at least distance of distinct vision, so v infinity, u will remain as it is, just like the previous one, just like this. Okay, then this thing, this condition we are going to substitute in this equation in Lenz's formula. Alright, so we have Lenz's formula here, 1 by f equals to 1 by v minus 1 by u. If you substitute these things, we are getting 1 by u is equal to 1 by f. So in the normal formula, what was that? This one, no? D by u, in place of u, what we can substitute? We can substitute f. So the formula becomes m equals to d by f. So this is formula number 2. This is for normal adjustment or for relaxed eye. So this is all about simple microscope. Now in this video we will discuss about the diagram of compound microscope. The derivation we will do in the next video. So in compound microscope, that is very important, because if the suppose if the derivation is not asked in the question, if you are only asked to draw the diagram, then also there will be 3 marks for only for this diagram. So the diagram you have to understand, and you can practice at home. Remember, for any ray diagram you must give these arrow signs. Okay, so compound microscope, there can be more than one lens, but generally we consider 2 lenses. One is called objective, which is near the object. One is called eyepiece, which is near the eye. Okay, from the figure it is clear, objective, the size is smaller, eyepiece, the aperture or size is larger. Okay, objective lens, okay, yes, size is smaller. Size means we call it aperture. Aperture means this diameter, this one. This is less. For which lens? For objective. And for eyepiece it is more. Now suppose this is the, okay, just a second, this is the object AB. From this object light ray is coming, it is parallel to principal axis. After refraction it will pass through the focus of the first lens. Okay, so this point should be the focus of the first lens. Alright, another one, directly it passes through the optical center, it meets at this point, and there will be formation of the image. Now this is the image A dash B dash. Now this image is formed by which lens? By the objective lens, by this lens, which is small in size, right? Now this image is behaving like object for the second lens. Alright, now a very important thing, that the system, the lens should be adjusted in this way, that this image, it should be formed in between the focus of this lens, FE, E for eyepiece, focus of this lens and the optical center of this lens. If it happens, if this image is formed in between focus and optical center, then it will satisfy the condition at which this lens will form a virtual and magnified image. You can see the simple microscope concept. In simple microscope, what was the concept? That the image was kept in between the optical center and focus, so that an enlarged magnified image can be formed. Alright, so if you just see this part, isn't it a simple microscope? That is a simple microscope. Okay, I think it is clear. So this image, finally this image, it will behave like object for this lens, and the final image will be formed at here, which is A double dash B double dash, and the image will be erect. But yes, this is erect for which object? For this object. But for the actual object, if this is the actual object, the object is like this and the final image is like this, so that means final image is also inverted, isn't it? So that is why the magnifying power, generally in some books you may get that the magnifying power is negative, minus. The reason is that this image is formed upside down, means it is inverted, so that is why magnifying power comes as minus. But in the derivation that I will do, there I have not considered this negative sign, but in some books you may get, so the confusion, you don't have to get confused, because negative sign only represents that the final image is inverted. Okay, so this diagram you practice at home. In the next video we will discuss about the derivation part. Here also the same thing, we are going to derive magnifying power, and magnifying power means it is a ratio between what? Alpha and beta. Alpha beta, what was that? Alpha was the it was the visual angle formed by the object at D, and beta is the visual angle formed by the final image. So okay, in this diagram you can see one thing, beta is drawn here. Alpha is I already told you that alpha is the angle made by the object in when we don't use any instrument, in naked eyes. Okay, so that is why alpha is not drawn here, but yes, beta is there, because this is the final image, this is the final image, and our eye position, generally, though I have drawn the eye here, but generally while drawing the angle we consider that our eye is somewhere at the optical center of the lens. So that is why if this is the image, this image at the optical center, how much angle it is subtending? It is forming beta. So this is the beta angle. Okay, alpha angle means alpha means you have to consider the, as I already told you, if this is our normal eye somewhere here, okay, if this is the object, then the object is it is subtending some angle at the eye, this angle, this will be alpha. No instrument is required in this case. Alright, so then in the next video we will find out the magnifying power, that is the ratio between 10 beta and 10 alpha. Thank you.